In this video, we're going to learn how to do Euler diagrams. So Euler diagrams are going to be used to do arguments. So we've done truth tables for arguments, but this time we're going to use something a little bit different. This will particularly be useful in dealing with arguments that involve quantifiers. So recall there are two types of quantifiers, universal and existential. So the universal quantifiers, remember those were those words like all, each, every, none, and existential were those words like some, at least one, or not all. So quantifiers can be difficult to express in symbols and then translate them well into truth tables. So here's a different take on what to do to test that kind of argument. So first I want you to look at some examples of what happens with the quantifiers. So Euler diagrams are made using circles, which will probably remind you of Venn diagrams. The circles represent the statements, which are shortened to a letter or a single word in the diagram, just to make things easier. So all, that's this first one on the left, all P's are Q's. If I want to say all P's are Q's, it means everything that's a P is also a Q, so I want to put P inside of Q. That should always be the case. You should always have the first statement inside of the second statement if it says all. Versus, what if I said some P's are Q's? So some doesn't have that completely inclusive. It just means there's some overlap, so there's some similarity there. This looks more like the Venn diagrams you were used to, so this kind of looks like a subset kind of feel, and this just looks like an intersection kind of feel. Okay, no P's or Q's means completely don't let them touch, right? There's nothing in common between them, so you want to pay attention to these quantifiers. All goes inside, some doesn't overlap, and then no means don't touch. So now when I test an argument, the arguments will still be composed of premises and a conclusion. That won't change. The Euler diagram should be drawn to reflect all the premises. The conclusion will be valid if the premise make the conclusion true. The argument will be invalid if we can draw the diagram in a way that reflects the premises being true but doesn't also make the conclusion true. Hopefully a few examples will help out, and because I know that you probably need more examples, this is going to be part 1 of 2. I'm going to have a second video on this as well. So just watch this first one to get the beginning feel, and then I have a second one that will kind of help out by doing more. All right, so what if we had this example? All skyscrapers have elevators. The Chrysler building has an elevator, therefore the Chrysler building is a skyscraper. Number 1 is do not add any information, right? You can only go with what I tell you. So I said the Chrysler building. Maybe some of you have been there, but I could have made up the Barker building, right? Because that's my name. You don't want to say just, well, I've been there and I know it. Don't use that. Only use what I tell you in the argument. So the argument said all skyscrapers have elevators, right? So I start with 2 circles, skyscraper and elevator. Okay, so that's my start. All is inside of elevators. Then it says the Chrysler building has an elevator. Now the only thing I know is the Chrysler building has an elevator, so I decided let C be the Chrysler building, and I put it inside the elevator circle. I can't put in the skyscraper because I don't know if that's true or not. So therefore, the Chrysler building is a skyscraper, not according to what I was told. So this argument is invalid, right? The diagram shows that all skyscrapers have elevators, and it shows the Chrysler building has an elevator, but there's no guarantee that this building is a skyscraper. Okay. So that's just me talking more. So let's talk about drawing Euler diagrams. Valid arguments are easy. The conclusion will be strong. The premises will not have multiple ways they can be placed on the page. Invalid arguments have multiple ways the information can be written. Because the information is weaker, it means the conclusion is not strong, and you need to draw the diagram in a way that contradicts the conclusion. All right, so let's look at this one. Some houses have pools. Some pools have fences. Therefore, some houses have fences. All right, so let's start with my first statement. Some houses have pools. I know that some means overlap, so I have houses and pools and I have an overlap. Then it says some pools have fences. Now the only thing that it talks about there is pools and fences, so I want to add the fence circle over to touch the pools. All right. Therefore, some houses have fences. Well, not according to what I was told. I wasn't given enough information for that to be true. So it's important that when I added that fence circle, I need to make it work where the premise still makes sense. So my houses have pools, some of the pools have fences, but there was nothing that guaranteed that any houses have fences. Okay, so let's try again. This one I said all cats are felines. All felines are mammals, therefore all cats are mammals. So I'm going to start with all cats are felines. So I can see I have cats inside of felines. Then it says all felines are mammals. So felines needs to be inside a bigger circle that's mammals. Now looking at it, I can see cats are inside the mammals, so that does say yes, this is a valid argument. So let's try another one. No professional football players are women. Some professional football players are golfers. Therefore, no golfers are women. All right. So what did I start with? I started with my circles for women and professional football players, and I made sure they weren't touching. So women, football players, completely disjoint away from each other. Then I wanted to add in some professional players are golfers, so I needed to add a circle for golfers. And the question was, where should I put it? Should I just make it touch the football players over here, or was it allowed to touch the women, which it kind of is allowed? So remember we talked about that if something's not a strong argument, we're going to have choices. So I had choices. I could not touch the women. I could make it touch the women. And because I had that choice, I want to show this is not a good argument. So I'm going to put it right here, kind of looking a little Mickey Mouse in the middle with big ears, right? So therefore, no golfers are women. I can't say that. You didn't give me enough information to make that valid. So I say this is not a good argument. It's invalid. All right, so let's try a different way. Here I said all quarterbacks play football. Okay, so all means I need to have quarterbacks, my all thing inside of football, what they do. So here's this circle inside of football. So quarterbacks inside of football. Then I said Tom Brady plays football. Okay, so Tom Brady, I need to put him inside of football. So I called him TB for Tom Brady. So can I decide therefore that Tom Brady is a quarterback? Not according to what was said here. And I know we all know Tom Brady plays football, but we know that, right? You could definitely come across a person that doesn't. Say you go to a different country, they're not going to care anything about Tom Brady or know who he is. You can maybe go home and ask your mom, and she may or may not know. I don't know that my mom knows who Tom Brady is. So you just have to go with, you can only use the information given in the statement. You cannot add any of your own personal information to the argument. So just because you know something about Tom Brady being a quarterback doesn't mean you can use that to make this a valid argument. You have to stick to what's in the sentences only.